The second question, show that the relation R in the set R of real numbers defined as R is equal to A comma B such that A is less than or equal to B square is either reflexive nor symmetric nor a transitive. So you have to prove that this relation is not reflexive nor symmetric nor transitive. So they have given us a relation that A comma B where A should be less than or equal to B square. So we have to check for, first we will check for the reflexive. So for reflexive we'll check. So for reflexive we know that that A comma A should belongs to R for every A belongs to set R. So set R is what? It's a real number. So we have to check for all the values that it is satisfies or not. So this means that here it is A is less than or equal to B square. That is, so here it should satisfy that A is less than or equal to A square. If this condition is satisfied, then only we call it as a reflexive. So for that we'll take a few values, like the first, the value of A, then the value of A square. So here we'll take few values, that is how it works. So first, if we are taking as 1, so 1, so if you are taking 1, so 1 square is nothing but it is a 1. So where 1 is equal to 1. So this is transitive. Sorry, it is reflexive. Yes, it is a reflexive because 1 is equal to 1. This condition satisfies with 1. Now if we take as 2, then 2 square is nothing but the 4, where 2 is less than the 4. Yeah, this condition also satisfies. This satisfies only for the whole numbers or for the negative numbers. So if we let us take something else number which does not satisfy the condition. Like let us take a half. So if I am taking half, then half square, 1 by 2 square is nothing but 1 by 4. So it is what? It is nothing but 1 by 2 is what? 0 0.5. So 1 by 2 is 0 0.5 is less than or equal to 0 0.25. Is it correct? Because 0 0.5 is greater than 0 0.25. So this does not satisfy the reflexive condition. So this does not satisfy any one value. If it does not satisfy a reflexive condition, then it is not a reflexive. So how do we write? Hence A less than or equal to A square is not true for all the values of A. So the given relation is not reflexive. So the given relation is not a reflexive. Okay. So now we have to, it is not a reflexive. Now we have to check for the symmetric. So we have to check for the symmetric. So here the symmetric, what we will tell that if A comma B belongs to R, then B comma A should also belongs to R. That is means if A is less than or equal to B square, then B is less than or equal to A square. So this both the condition it should satisfy. So we'll take a few values and we'll check whether this works or not. So first, if we are taking, so it is the value of A, the value of B, A square, B square, where A is less than or equal to B square, then B is less than or equal to A square. So we'll take few values and we'll check that whether this satisfies or not. So the first, if I am taking has value has 2 and 3, I'll take 2 and 3. So 2 and 3 means what is 2 square will be 4 and 3 square will be 9. So here A is what? A is 2. 2 is less than or equal to b square. B square is what? 9. Yeah, of course, 2 is less than or equal to 9 square. So this condition satisfies. So this term means 2 comma 3 exists. And next is b is what? It is 3. 3 is less than or equal to a square. A square is 4. Yes, even 3 is less than 4. So yes, so 3 comma 2 also exist in the relation. So this condition satisfies for both. Now let us take one more value as 2 and 4. So 2 square is again what? A 4. 4 square is 16. So here 2 is less than or equal to 16. Yes, it satisfies. So 2 comma 4 belongs to R. Now we'll check for B. B is what? B is 4 is less than or equal to 4. Yes, because a square is 4. 4 and 4 is equal. Yes, this condition also satisfies. Means 4 comma 3 also belongs to a relation. Now we'll take some other number which has a lot of difference. Like I'll take 2 and the 5. So 2 square is 4. The 5 square is 25. So you know 2 is less than or equal to 25. Yes, this condition satisfies. Means 2 comma 5 exist in our relation. The next is 5 is less than or equal to 4. So 5 can be less than or equal to 4. No, it's not. So this cannot be possible. So no, it does not satisfy the condition. So 5 comma 2 does not exist in the relation. So it cannot be symmetric. So since b is less than or equal to a square is not true for all the values of a, so the given relation is not symmetric. So it is not a symmetric. So next we have to check for the transitive. Transitive. So in transitive, what do you tell? If a AB belongs to R and BC belongs to R, then AC should belongs to R. So here AB belongs to R, then BC belongs to R, then AC should belongs to R. So here we'll take a few values and we'll check how it is. So here the condition is what? A is less than or equal to B square and B square is less than or equal to B is less than or equal to C square, then A is less than or equal to C square. So it should satisfy these three conditions, then only those elements will be in our relation. So we'll take few values: A, B, C, B square, C square, A is less than B square, and B is less than or equal to C square, and A is less than or equal to C square. So we'll take the values and we'll check that whether this is going to satisfy the condition or not. So first we'll take 1, 2 and 3. Here the A value is 1, B value is 2 and C value is 3. So B square is nothing but 2 square is 4 and C square is 3 square is nothing but the 9. So A is what? A is 1 is less than or equal to B square, that is 4. So 1 is less than or equal to 4. Yes, of course 1 is less than 4. So 1 comma 2 is there in a relation. Then next we have B. B is 2 less than or equal to C square. C square is nothing but 9. So that is 9. Yes, 2 is less than 9. Yes, 2 comma 3 also exist in our relation. Now next is we have A. A is 1 and C square is 9. So 1 is less than or equal to C square. Yes, because 1 is less than or equal to 9. Yes, this also there. So we have 1 comma 3 also in our relation. So this will satisfy our transitive, but we have to check that question is told it is not a transitive. So we have to take such a values where it proves it is not a transitive. Let's take negative values. So minus 1, minus 2 and minus 3. So this will be 4, 9. So what will be this? Minus, so you have minus 1 is less than or equal to 4. Yes, minus 1 is less than or equal to 4. It is satisfies the condition. Again, minus 2 less than or equal to 9. Yeah, minus 2 is less than or equal to 9. Yes, this also satisfies, means minus 2 comma minus 3 is also there. Again here minus 1 is less than or equal to 9. Yes, this is also there, means minus 1 comma minus 3 also is there. So yes, this condition also satisfies. So it is also saying that it is a transitive. Let's take a positive and negative numbers. So here if we take 2 minus 2 minus 2 and 1, so a will be 2, b will be minus 2 and c will be minus 1. So b square it will be plus 4 and c square will be plus 1. Okay, so now 2 is less than or equal to 4. So a is 2, my b square is 4. Yes, this condition satisfied. So 2 comma minus 2 exist in the relation. The next b is minus 2 less than or equal to what it is. C square is nothing but 1. Yes, minus 2 is less than 1. Yeah, and this ordered pair minus 2 comma minus 1 also exist in the relation. The next a is 2 less than or equal to what is c square? C square is 1. So 2 is less than or equal to 1. No, it's not, because 2 is greater than 1. This does not satisfy because this is not equal to. So this is not a transitive. So it is proved that no, not for all values it is a transitive. So if a is less than or equal to b square and b is less than or equal to c square, then a is less than or equal to c square is not true for all the values. So it is not true for all the values of a comma b comma c. So it is not true for all the values of a comma b comma c. Hence the given relation is not transitive. So we have proved that this is not reflexive, not symmetric, and not transitive. The third question, check whether the relation are defined in the set 1, 2, 3, 4, 5, 6 has R is equal to A comma B, that is B is equal to A plus 1 is a reflexive, symmetric and transitive. So in this question, they have given that the set that is 1, 2, 3, 4, 5, 6 is their set, and the relation is told that A and B, where B should be equal to A plus 1. So here first we have to, here they have asked us to check whether it is reflexive, symmetric or transitive. So first we will check for the reflexive. So we have to check for the reflexive. So as we know what is reflexive, if a relation is reflexive, then if A comma A belongs to R. So here all A comma A should belongs to R. So here even here they have given us that A comma B. So even B also we have to take value of the A. So if we take for an example, that is A and A plus 1. So if we take an A value, so we have to check that A and A plus 1 should be equal. So if we take a value as A is equal to 1, then the value will be 1 plus 1 is 2. So 1 plus 1 is 2. So 1 and 2 cannot be equal. So A and A plus 1 cannot be equal. So since A is equal to A plus 1 cannot be possible for any value of A. So therefore R is not a reflexive. So next we have to check for the symmetry. So a relation is symmetric. We tell that if relation is symmetric, if AB belongs to R, then BA also should belongs to R. So here we have AB belongs to R, then BA also should belongs to R. Then we call it as a symmetry. So let's take an example. We have to have A plus B, and B plus. So we have to take A plus 1 and B plus 1. So if we take a value has 1, I'll take a value A has 1 and B has 2. So A is 1 plus 1 is 2. The B value is 2. So 2 plus 1 is 3. So if we take, if 1 comma 2, if 1 comma 2 belongs to R, that implies that B is equal to A plus 1. So here we have given B is equal to A plus 1. So A value is nothing but a 1. So 1 plus 1 and the B value is 2. So you can see the both A value and after adding is same, 2 and 2 same. So this 1 comma 2 belongs to R. Same thing if we take ulta, that is for B comma A, means we have taken 2 comma 1. So we are checking for 2 comma 1 does belongs to R or not. So here we are getting A is equal to B plus 1. So B plus 1, that implies the B value is what here? B value is, A value is 1 and B value is 2. So 2 plus 1 is nothing but 3. So 1 and 3 cannot be same. So we say 2 plus 1 does not belongs to R. So this is not a symmetric because 1 comma 2 belongs to R, then 2 comma 1 also should belongs to R because ulta of 1 comma 2 should also belongs to R. Therefore, R is not a symmetric. Next, we will check for the transitive. So, if a relation is transitive, if A and B belongs to R and B and C belongs to R, then AC should also belongs to R. So here we have that. So for this A comma B, for A comma B, we'll have B is equal to A plus 1, and for B comma C, we'll have C is equal to A plus 1. Then for A comma C, again for A comma C, we have C is equal to B plus 1. And for C is equal to A plus 1. So we'll take a value and check whether that this satisfies a condition or not. So here A, B, C, and here you have A plus 1 and B plus 1. So if we take a value of A has 1, B has 2 and 3. So A is what? 1. So 1 plus 1, you get it as 2, and B value is 2 plus 1, you get it as 3. Now we will check for each values. So here if we take 1 comma 2, that is A comma B. So what is A comma B? For A comma B, it is 1 comma 2 belongs to R. That implies that B is equal to A plus 1. So what is the B value? That is, what is the B value? B value is 2. 2 is equal to A value is 1. 1 plus 1. So 2. So I get value 2 on the both side. It is belongs to R. Now second, if we are taking B comma C, I have to take B comma C. So value of B comma C is 2 comma 3 belongs to R. That implies that, so I'll get C comma B plus 1. That is C, what is the value of C? C value is 3. So 3 is equal to B value is my 2. 2 plus 1 is 3. So both are same. So my 2 comma 3 also belongs to R. But now if we are checking for Now if you are checking for 1 comma 3, that is for a comma c, that is 1 comma 3, so you get c is equal to a plus 1. So c is equal to a plus 1, that is, so what is c value? C value is 3. My a value is 1. So 1 plus 1 is 2. So which is not equal. So c is not equal to a plus 1. That is 1 comma 3 does not belongs to R. Therefore, R is not a transitive. So here they were asked us to check a relation whether it is reflexive, symmetric or transitive. But we have proved that the relation is not reflexive, not symmetric or not transitive. Fourth question, show that the relation R in an R defined as R is equal to A comma B, that is A is less than or equal to B, is a reflexive, transitive but not symmetric. So they have given us a relation is A comma B is such that A is less than or equal to B. So we have to show that it satisfies reflexive, transitive but not the symmetric. So here we have to take out some example to show that it is reflexive, transitive but not symmetric. So first we will check for the reflexive. So a relation is reflexive if we tell that if relation is a reflexive if a comma a belongs to R. So a comma a should belongs to R. So here I am taking a comma b, instead of b I have to take a. So that is a is less than or equal to a. So you know that a is equal to a. So the number is equal to itself only. So this condition is satisfied. So that is nothing but a comma a belongs to R. So therefore a comma a belongs to R. So R is a reflexive. So R is a reflexive. Now we have to check for the symmetric. So a relation is symmetric. If we tell that relation is a symmetric, if a comma b belongs to R, then b comma a should also belongs to R. If b comma a belongs to R, then b comma a also should belongs to R. So here if I take one example, that is 1 comma 2 belongs to R, that is implies that 1 is less than or equal to 2. So obviously 1 is less than 2. So 1 comma 2 belongs to R. But when we take this as ulta for b comma a, that is 2 is less than or equal to 1 is not possible because 2 is greater than 1. So this is not possible. Therefore 2 comma 1 does not belongs to R. Therefore R is not a symmetric. Okay. The next we have to check for the transitive. So we have to check for the transitive. So when we say transitive, if a relation is transitive, then so if what is a comma b should belongs to R and b comma c should belongs to R, then a comma c should belongs to R. If a comma b belongs to R and b comma c belongs to R, then a comma c should also belongs to R. So we'll take a simple example that 1 comma 2. So 1 comma 2 belongs to R. That implies that 1 is less than 2. So 1 is less than 2. So 1 comma 2 belongs to R. Now if we take 2 comma 3. So 2 comma 3 belongs to R. This implies that 2 is less than 3. So if 2 is less than 3, we know that 2 is less than 3. So next is we have to check for this a comma c, that is but if you take 1 and 3, 1 is less than 3. So obviously 1 is less than 3. So it is true. So even 1 comma 3 also belongs to R. So therefore R is a transitive. So it is a transitive. So we have to show that the relation is a reflexive and transitive, but it is not a symmetric. Question number 5. Check whether the relation R in R defined by relation is A comma B such that A is less than or equal to B cube is reflexive, symmetric or transitive. So in this question, the relation R, where R is given as A comma B such that A is less than or equal to B cube is reflexive or symmetric, we have to check. So first we will check for the reflexive. So if a relation is said to be a reflexive, so A comma A should belongs to R for every A value of the relation. So here we have to take, instead of A comma B, we have to take A comma A. We'll see through example, that is 1 comma 1. So is 1 is less than or equal to 1 cube itself. So 1 is always 1 is less than or equal to cube. If you take any values for 1, 2, 3, usually it will be less than the its cube only. So let's take an example like fraction numbers, because it's a real number. So we'll take 1 by 2 comma 1 by 2. So we'll check whether this will work, will satisfy or not. So 1 by cube is less than or equal to, so 1 by cube 1 by 2 cube will be 1 by 8. So is less than, or we have to check. So we know that 1 by 2 is nothing but 0.5 and 1 by 8 is nothing but 0.125. So we know that 1.5 is always greater than 0.125, which is not equal. Here it should be 0.5 should be less than 0.1 by 2, but it is greater. So hence, so here A is less than or equal to A cube is not true for all the values of A. Here 1 by 2 belongs to R, where 1 by 2 does not belongs to R, because 1 by 2 is greater than 1 by 8. So which is not possible. So 1 by 2 and 1 by 2 does not belongs to R. So 1 by 2 is greater than 1 by 8. So we tell that this is not a reflexive, because it does not satisfy for all the, means it is not true for all the values. So R is not a reflexive. Next, check for the symmetric. If a relation is said to be a reflexive, if A comma B belongs to R, then B comma A should also belongs to R. So here A comma B should belongs to R and B comma A should belongs to R. We'll take few example and we'll check. So let's take A, B, A cube and B cube. Let's take 1 and 2 for A and B. So 1 cube is nothing but a 1 only. So and B is 2, so B cube is nothing but 8. So here if we take 1 comma 2 for AB, so 1 comma 2 is what you have to check, that A is less than B cube, that is 1 is less than 8. So it is true, because 1 is always less than 8. Now let's take B comma A. So B is 2 and A is 1. So B is less than or equal to 1 cube, where you can see that 2 is greater than 1. So hence it is not true. So hence we write it as 1 comma 2 belongs to R, that is 1 is less than or equal to 8. So here 1 is less than or equal to 2 cubed, that is 1 is less than or equal to 8. Yes, it is true because 1 is always less than 8. So it is true for this. So 1 comma 2 will belongs to R. Now we have to check for B comma A, where B value is 2 and A value is 1. So we'll get 2 is less than or equal to 1 cube. That is 2 is less than 2 is less than or equal to 1, where 2 is greater than 1, which is not true because here they have given has 1 should be less than, but 2 is greater. So hence 2 comma 1 does not belongs to R. R is not a symmetry. So next we will check for the transitive. So if a relation is said to be a transitive, if A comma B belongs to R and B comma B comma C belongs to R, then A comma C should also belongs to R. So we'll take an example to show that. So we are taking A, B, C, that is A cube, B cube and C cube. So we'll take as first we'll take as 1, 2 and 3. So 1 cube is 1, 2 cube is 8 and 3 cube is 27. So 3 cube is 27. So here they have asked that A is less than or equal to B cube. So if you are taking A and B, that is 1 and 2. So 1 is what? 1 is less than 8. Of course 1 is less than 8, it satisfies. So 1 and 2 belongs to R. Next we are taking 2 and 3. If you are taking B and C, so for B and C it is 2 and 3. So 2 is less than or equal to 27. Of course 2 is always less than 27. This is condition also proves. Now we have to take A comma C. For A comma C is 1 comma 3. So for 1 comma 3, 1 is less than 27. Of course this is proved. So this condition is satisfying for this. Let's take for other example like fractions. So if we are taking for value for 3 and 3 by 2 and 4 by 3. So if we take these numbers, so A is 27 and 3 by 2 is nothing but 1.5. So 1.5 cube root is 3.375 and 4 by 3 cube root will be 2.37, cube will be 3.7. So now let's check for this. So A, if you are taking 3 and 3 by 2, then 3 is less than 27. Of course 3 is less than 27, that is proved. Next if you are taking B and C. So B is how much? It is 3 by 2. So 3 by 2 is nothing but 1.5. 1.5 is less than 2.37. That is also proved. The next we are taking A and C, that is 3 and 4 by 3. So 3 is less than 2.37. No, because 3 is greater than 2.75. So we write it as here. So here 3 comma 3 by 2 belongs to R. So that is A is less than or equal to B cube. That is nothing but 3 is less than or equal to what is B cube? B cube is nothing but a 3 by 2 cube. So it is 3.75. 3.375. So it is 3 is lesser than 3.375. So this is a 3 by 3 comma 3 by 2 is belongs to R. The next one, if you're taking for B comma C. So B comma C is what? 3 by 2 and 4 by 3 belongs to R. That is B is less than or equal to C cube. That is, so here what it is 1.3 by 2 have to, it is nothing but 1.5 is less than or equal to, so 3 cube. So C cube is what? It is 4 by 3 cube is nothing but 2.37. So 2.37. So 1.5 is less than 2.37. It is belongs to. But But so here we have taken that a is less than or equal to c cube. So we have to take a is less than or equal to c cube. That is, what is a? A is 3. Less than or equal to, what is c cube? C cube is 2.37. So 2.37, which is not equal because 3 is greater than a. So it is not possible. So therefore, 3 comma 4 by 3 does not belongs to R. Therefore, R is not a transitive. So here in this question, we have proved that a relation R is not reflexive, nor symmetric, nor transitive. So sixth question, show that the relation R in the set 1, 2, 3 given by a relation 1, 2 and 2, 1 is a symmetric but neither a reflexive nor a transitive. So they have given, this is a simple question, they have given a relation telling that 1, 2, 3 is a set. So they have given a relation that is 1, 2 and 2, 1 is, you have to find out whether it is a symmetric and it is not a reflexive and transitive. So first we will check for the reflexive. So reflexive, what we tell that a relation is reflexive. So if we are telling that relation is reflexive, if A comma A belongs to R, for every A belongs to A. So here all the A, what are the values? 1, 2 and 3. So I should have 1 comma, so here I should have 1 comma 1. Does 1 comma 1 belongs in the relation here? No, it's not there. 1 comma 1 is not belongs to the relation. So 1 comma 1 does not belongs to the relation. So therefore R is not a reflexive. So it is reflexive because 1 comma 1 does not belong in the R. We don't have R. Now we'll check for the symmetry. So a relation is symmetric. So if relation is symmetric, if you are telling that relation is symmetric, if A comma B belongs to R, then B comma A also should belongs to R. So here A comma B is there in the relation, then B comma A also should be there in the relation. So here we are taking 1 comma 2. So 1 comma 2 belongs to R, then 2 comma 1 is also there in the R. So therefore R is a symmetric. Transitive. Transitive. If, so we are telling that if it is a transitive, then if A comma B belongs to R and B comma C belongs to R, then A comma C also should belongs to R. So here we are taking that, so here 1 comma 2 is belonging to the R. We know that 1 comma 2 is there and 2 comma 1 is there belonging to R. But 1 comma 1 is not belong in the R because 1 comma 1 is not there in the relation. So therefore R is not a transitive. Thank you for watching. Please subscribe.